So this is problem number 25 of GATE 2020 Metallurgical Engineering. The question is, the number of atoms per unit area in 100 plane of lead is given. Crystal structure and atomic radius of lead are FCC and 0.175 nanometer respectively. So you can refer NPTEL reference for this problem on crystal structure, lecture number 4 of Basics of Materials Engineering course by Professor Ratnakumar from IIT Madras. So let's have a look on FCC crystal structure, how it looks like. So if you see FCC crystal structure, it has a corner atoms, 8 corner atoms. You can see 4 here at the top, these 4, and 4 at the bottom plane, and then each faces, there are total 6 faces. On each faces one atom will be sitting, right? So to have a more clear view, I have another image. So you see like how the atoms are sharing in the unit cell. So in the problem they are basically asking the number of atom per unit area in 100 plane. So 100 plane is basically this facial plane. So it can be this depending on the reference, which reference you are talking about, like origin where you are defining. So let's say that this is our 100 plane for the time being. So basically in 100 plane we have 4 corner atoms and 1 face center atom, and corner atoms are giving 1/4 of contribution in terms of area, like only 1/4 of area you can see on this 100 plane, and this face center atom is basically completely covering entire area for this particular plane, right? So basically in this problem they are asking about the planar density of 100 plane. So let's learn what is planar density. So planar density is defined as number of atoms centered on a plane upon area of that plane. So if you talk about FCC 100 plane, so let's first calculate the number of atoms centered on 100 plane of lead, right? So basically we have 4 corner atoms with the contribution 1/4, so 1/4 of corner atoms, and we have total 4 corner atoms. So effective number of atoms which are covering on this plane from the corners are 1/4 from each and total 4. So 1/4 into 4 plus this face centered atom, right? So it's totally covering, like entire atom is coming under this particular plane. So one atom into the entire area, like unit, this total area. So 1 into 1. So if you solve this, we will get 1 upon 4 into 4 plus 1 into 1 will give you 2. So the number of atoms centered on 100 of lead is 2. So we get that. Now area of this plane. So area of this plane will be, let's say the lattice parameter of this unit cell is A. So we have this much distance equals to A unit, right? And also the radius of one lead atom is R. So if you see the total diagonal length, this much is R, this much will be 2R, and this much will be again R. So total 4R, and the diagonal of this square will be equals to root 2 times A. So root 2 times A will be equal to 4R, right? So this is a relation for this FCC unit cell. So we have root 2A is equal to 4R. So A will be equal to 4R upon root 2. Similarly, if you try to find the area of plane 100, so area of plane 100 for lead will be equals to A square. So this A square, right, square of the lattice parameter will give you the entire area. So you put the value of A, it will be equal to 4r upon root 2 whole square equals to 16r square upon 2, which will further give you 8r square. So the area of plane 100 is equal to 8r square. Now we got the area, we got the number of atoms centered on 100 plane. So now we'll calculate the this planar density, right? So planar density will be number of atoms centered, which is equal to 2 here, and the area of plane 8r square. So it will be equal to 1 upon 4r square. So we'll put the value of r. So r value is given as 0.175 nanometer whole square. So if you solve this, we will get the planar density, or the number of atoms per unit area on 100 plane of lead equals to 8.16 nanometer to the power minus 2. So the correct answer is 8.16. Right. Thank you.